So this question initially it looked like intimidatingly long and slightly long-winded, quite frankly. You're hosting an exclusive party such that the guest is only allowed to come in, etc., etc. So the trick here is to you immediately know, because of the context that this is a graph question. Trick is, let's just break it down into graph facts. So they're only allowed to come in if they are friends with you or someone else already at the party. So every vert has degree of v at least 1, because every person knows at least one other person already at the party. And we also know that because they're connected to somebody else who's already at the party, we're now graph connected. Yeah. After everyone's showed up, you notice that there are n people, so n vertices. Everyone has at least one friend, so every vertex has degree above 1, like we saw. And we also know there are only n-1 friendships. And in this case, a friendship is just a connection, is just an edge, so n-1 edges. And like these facts indicate something interesting, which is like a connected graph on n vertices with n-1 edges. Therefore, graph is a tree. And trees are lovely because we can do lots of things with them. So then it says you want to play a game with two teams, and you want to group them such that within each team, no one is friends with the other. And again, translating this into the language of graphs. Within each team, no edges, only between teams. And, well, you'll realize from here that, especially given the hint that suggests we use the previous question somehow, our notion of teams here corresponds to our notion of colors from the previous question. So we can say, well, the graph is a tree, so we can get a set of A vertices that are colored red, and a set of B that is colored blue vertices. This arises from a fact. Yeah. From question 1, we know that such a coloring exists, so we can sort of split the graph into A and B. And we also know that, like, by the definition of a graph coloring, if two nodes are within A, we will never have a connection between them, so we will never have an edge, or in this case, a friendship. And therefore, we can just color the graph, which we know we are allowed to do from the previous question, and then our colorings naturally give us teams. We can say everybody with the same color is on the same team. And so we have solved this very long-winded question by reducing it to a graph problem, which we solved previously.